Hello students, welcome to Academy, the place for mathematics and science. Dear students, let's continue the chapter triangles. And do remember, this is 9th period of this chapter. In the 8th period, we learned an important theorem related to right angle triangle. Can you name that? Yes, you are right. This is Pythagoras theorem, which is also known as Baudhayana's theorem. Dear students, once we shall go for recalling this theorem. Before that, let me show you weekly test 11 question paper. This is the question paper and the test was conducted on the chapter triangles and it was for 25 marks. These are the questions in first page. Go through them. And these questions are in second page. Please take the screenshot of both the papers and use them for practicing. Dear students, let's continue the chapter triangles. As I said, in the last class, we discussed Pythagoras theorem. Can you tell the statement of this theorem once? Yes, it is. In any right triangle, the square of hypotenuse is equal to the sum of squares of other two sides. Even we were solving some of the worked examples. Let's go for continuing that. Look here, this is second one. Very simple and is also important in the examination point of view, and it was given once in the examination for 2 marks. The statement is like this. In this figure, AD is perpendicular to BC. Then we have to prove that AB square plus CD square. See that AB square plus CD square is equal to BD square plus AC square. Okay, BD square plus AC square. Very simple statement. How can we go for proving? Yes, dear students, do one thing. First you copy this statement, then after that you may start writing with me. Yes. Here I'll write the proof. Look here, and you just go on writing with me. We want AB square plus CD square. Okay. AB, it is a side of a right triangle. What is that? It is ADB. Followed? Here, I'll write. In triangle ADB, angle ADB equal to 90 degree. If one angle is 90 degree, you can go for applying Pythagoras theorem for that. By Pythagoras theorem. Pythagoras theorem. How do you write? It is AB square is equal to AD square plus BD square. Because AB is a hypotenuse, which is square of this side is equal to AD square plus BD square. Next, you may call this as statement 1. Next, we want CD square. Therefore, I go for taking another right triangle, which is that it is ADC. Here, in triangle ADC, angle ADC is 90 degree. Again use Pythagoras theorem. By Pythagoras theorem. How do you go for writing? It is AC square equal to AD square plus CD square. AC square is equal to AD square plus CD square. See that here we have AB square plus CD square. AB square is already there. We want CD square, hence I go for solving CD square. CD square is equal to AC square as it is. Transfer AD square to the left hand side. It becomes minus AD square. Call this as statement 2. As there is sum of AB square plus CD square, I go for adding equation statements 1 and 2. Here I'll write adding statements 1 and 2. LHS part, what is that? AB square plus CD square is equal to RHS part. AD square plus BD square plus AC square minus AD square. Right? Observe, AD square get cancelled. What will remain? it is BD square plus AC square. Observe, BD square plus AC square, which is equal to AB square plus CD square. Hope that you have understood such a simple proof. You are right. Hence it is proved. Copy this. Dear students, please go through this one. This is very important type of problem. This will also be given for 2 marks and has been asked in the examination as well. So I put double star mark. Go through that. Such a simple statement. BL and CM are medians of triangle ABC. Right angled at A. Here they have given right triangle ABC. In that angle A is 90 degree. BL is the median. That means, see that AL will be equal to CL. Similarly, CM is the median. Hence, AM is equal to BM. And we have to prove that BL square plus CM square is equal to 5BC square. Is it not simple? Definitely. Observe them. Look at here BL. It is an hypotenuse of triangle BAL. CM square. CM is the hypotenuse of the triangle MAC. And BC, that is also the hypotenuse of a triangle CAB or ABC. Obviously, we should go for using Pythagoras theorem. Why? The reason is we have squares of the hypotenuse. Okay, let's go for proving. So, pause the video and copy from there to here. Yes, copy this. Yes, students, now let's go for proving this. And before that, just go for writing the data with me. What has been given? ABC is a right triangle. Here I'll write. In triangle ABC, it is angle A is 90 degree. Next, they are given BL and CM are the median. So first I'll write BL is the median. When BL is the median, how do you go for writing? AL equal to CL is half of AC. Right? Copy it. AL is equal to CL is equal to half of AC or AC by 2. Next. Similarly, CM is also a median. CM is the median. Then how do you write? AM equal to BM equal to half of AB. AM equal to BM is equal to half of A. This much has been given. Next, we should prove that. What is that statement to be proved? It is 4 times BL square plus CM square is equal to 5 times BC square. Let's go for proving. As I told, they are all the hypotenuse of the 3 triangles. Hence, we shall go for using Pythagoras theorem. First, BC. BC, it is a side of the right triangle ABC. Hence, I go for taking triangle ABC. In triangle ABC, how do you write? Angle A is 90 degree. Therefore, by Pythagoras theorem or Baudhayana's theorem, we can go for writing it as BC square equal to AB square plus AC square. Here again, BC square is equal to AB square plus AC square. You may call this as statement 1. Similarly, let's go for taking another triangle. See that BL and CM are required. What is BL? BL, it is in triangle LAB, angle A is 90 degree. Again, you no need to write by Pythagoras theorem. Directly you can go for writing BL square is equal to AB square, then AL square. AB square plus AL square. Call this as statement 2. Next, one more side, CM. CM, it is the side of the triangle CAM, right? Right. In triangle CAM, there also angle A is 90 degree. Use Pythagoras theorem. What is that Pythagoras theorem? It is CM square is equal to AM square plus AC square. Here, AM square plus AC square. Call this as statement 3. Observe here. Here BL square plus CM square is there. So here also BL square and CM square they are there in statement 2 and 3. What should be done with second and third, using second and third statement? Yes, you are right. We should go for adding them. Let us go for adding. Adding statement 2 and statement 3. First go for adding LHS part. BL square plus CM square, which is equal to RHS part. It is AB square plus AL square plus AM square plus AC square. Followed? Observe here. For AB square plus AC square, we have substitution. That can be written as BC square. But what about AL and AM? Hence, we shall go for taking substitution from them. AB square as it is, where AL is half of AC or AC by 2. AC by 2, then whole square. What about AM? AM is half of AB, nothing but AB by 2. Write it square plus AC square. This is because of these two statements. You may call this as statement A, this as B. In reason, write statements A and B. Followed? Okay. This is AB square as it is. Apply square to both. AC whole square is AC square by 2 square is 4. This is AB square by 4 plus AC square. In the denominator, 4 is there, right? Go for taking LCM of all the denominator. It will be 4. Multiply this LCM with all the terms. 4 into AB square, 4 AB square. Plus 4 into AC square by 4. Here 4 and 4 get cancelled. Only AC square will remain. Next, multiply 4 with third term. Again get cancelled. AB square. Multiply 4 with fourth term. It is 4 AC square, which is equal to, observe here 4 AB square, 1 AB square. How many times? 5 AB square. 5 AB square plus 1 AC square plus 4 AC square, 5 AC square divided by 4. Now you may take 5 as common factor. This is 5 into AB square plus AC square by 4. Followed? This is equal to, alright, BL square plus CM square as it is, equal to 5 into, what is AB square plus AC square? That has already been written in the very first part. AB square plus AC square is nothing but BC square. How we have written? It is based on the statement 1. Right? Next. This can be rewritten as, go for cross multiply 4 with LHS part. Here I am writing. 4 times BL square plus CM square is equal to 5 times BC square. Observe the statement to be proved. 4 times BL square plus CM square is equal to 5 times BC square. Hence it is proved. Please go for copying this. Yes. Dear students, go through this fourth one. It is also simple one. And in this figure, they have already given construction. But in the examination point of view, don't expect this construction. only they may give this much figure except PQ. Here O is any point inside a rectangle. ABCD is a rectangle. Prove that. See that OB square plus OB square plus OD square, this is equal to OA square and plus OC square. Here when you observe OB, OD, OA and OC, what you will think? Will they become the hypotenuse? Definitely. Here, as I said, they only have given the construction. Here, as it is a rectangle, each angle will be 90 degree. This is 90 degree. What about this angle? It is also 90 degree. Why? Corresponding angles. Here, these two are corresponding angles. Hence, we get two rectangles. Followed. That is one thing. Then, as it is perpendicular, then OB will be the hypotenuse, OA will be hypotenuse, OD will be hypotenuse, even OC also. Hence, we can go for using Pythagoras theorem. Got it? Now, first, you may pause the video to copy this whole statement with the geometrical figure. After that, you can start writing with me. Yes, start. Here, they have given ABCD is a rectangle. ABCD is a rectangle. Next, if it is rectangle, we know that each angle is 90 degree. Angle A equal to angle B is equal to C is equal to angle D, which is equal to 90 degree. Even opposite sides are equal. I write AB equal to DC and AD equal to BC. AD equal to BC. This much. With this information, we should prove that what? We have to prove OB square plus OD square equal to OA square plus OC square. As I told, in the examination, they won't give this dotted line. We have to assume. Hence, I go for writing the construction. What is that construction? Draw PQ parallel to BC or parallel to AD through O. Here I write construction. Start writing with me. Draw PQ parallel to BC through O. Followed? Yes. Now let's go for proving. In proof, we can come to know that OB is the hypotenuse, but if it is to be hypotenuse, this BPO should be right triangle. But do you say that it is 90 degree? Yes. How? Because it is angle A equal to angle BPO. Follow? The reason? Corresponding angles. Here right. Angle BPO is equal to angle A. Angle A equal to 90 degree. The reason? Corresponding angles. Next, similarly, here as well. Okay, this angle. Angle D equal to angle CQO. Angle CQO equal to angle D, which is equal to 90 degree. The reason is same. Corresponding angles. As they are 90 degree, we can say that OP is perpendicular to AB. OQ is perpendicular to DC. Right? With this information, we can write APQD is a rectangle. BPQC is a rectangle. You all may be thinking that, sir, rectangle is a parallelogram in which each angle is 90 degree. Or rectangle is a quadrilateral in which opposite sides are equal and each angle is 90 degree. Right? Here also, look here. As OP is perpendicular to AB, this angle is 90 degree, this angle is 90 degree. Then here OQ is perpendicular to DC, these two angles are 90 degree. Look here. We know that angle B and C are 90 degree. A quadrilateral in which each angle is 90 degree. Which is that one? It's a rectangle. Followed? So now here we'll write OP is perpendicular to AB and OQ is perpendicular to DC. Next, therefore, alright, APQD and BPQC are rectangles. Followed? Okay. Next. Now we shall go for using Pythagoras theorem for these triangles. First, I'll take the triangle APO. In triangle APO, angle APO is 90 degree. Therefore, you can apply Pythagoras theorem. According to Pythagoras theorem, how do you go for writing? It is OA square equal to OB square plus AP square. OA square is equal to OP square plus AP square. You may call this as statement 1. Next, in triangle which is BPO, in triangle BPO, which angle is 90 degree? Angle BPO is 90 degree. Here already we have written by Pythagoras theorem once, hence you can go for writing it directly. OB square is equal to OP square plus BP square. Call it as statement 2. Next, let me go for taking the third triangle, that is CQO. In triangle CQO, angle CQO is 90 degree. Again by Pythagoras theorem, we can write OC square is equal to OQ square plus CQ square. Call this as statement 3. Next, in triangle DQO, fourth triangle. In triangle DQO, angle DQO is 90 degree. By Pythagoras theorem, OD square equal to OQ square plus DQ square. Call it as statement 4. Observe. Here we shall go for writing OB square plus OD square. Okay. OB square plus OD square. Here is. Hence we can go for adding second statement 2 and statement 3. Got it? OB square and OD square. Adding statements 2 and statement 4. Statement 2 is OB square plus statement 4 in that LHS part is OD square, which is equal to RHS part OB square plus BP square plus OQ square plus DQ square. Followed? See, we need OA square plus OC square, where OA square is OP square plus AP square. OP is already there. There is no AP square. Next, OC, we want OC square. OC square is nothing but OQ square plus CQ square. OQ square is there, but we don't have CQ square. Hence, I go for taking substitution for remaining these two. This and this. I'll write OP square as it is. What about BP square? See that BP is nothing but CQ, right? Why? We also know that BPQC is a rectangle. In a rectangle, opposite sides are equal. Alright. In place of BP, I'll write CQ square. CQ square plus OQ square as it is plus dq square. What is dq square? It is nothing but AP square. You are right, AP square. In bracket you may write the reason that because opposite, or else you can write BP equal to CQ and DQ equal to AP are opposite sides of rectangles. Sides of rectangles. There I don't have space, so that in bracket I have written. Let me continue here. This is equal to, what is OP square, and see that OP square as it is, we want, we have CQ square plus OQ square plus AP square. I'll take OP square plus AP square. What is that? OP plus AP square, it is OA square. Plus, next, observe here, CQ square plus OQ square. CQ square plus OQ square is OC square. So, these two have been written from statements first and third. So, LHS part is OB square plus OD square, and RHS part is OA square plus OC square. This is the statement which has been proved. Dear students, hope that you have understood this completely. So now you are right, hence the given statement is proved. Now you can go for copying from there to here. Dear students, please go through the statement and is important in the examination point of view. It has been asked for 1 mark as well as 2 marks. See, 1 mark just giving you the figure like this, and they'll give you the sides. Then after that, they'll ask you to find out BC square by AC square equal to dash. If you know BD and AD, you can write them. Okay, first you go through the statement. In this figure, ACB is 90 degrees. See that angle ACB, this is 90 degrees. And CD perpendicular to AB. With this information, we have to prove that BC square by AC square equal to BD by AD. Then how to do that? Look here, of course, as it is perpendicular, you can go for using Pythagoras theorem. See that BC square is BD square plus CD square. Whereas AC square is AD square plus CD square. And dividing, will we get BD by AD? See that we get BD square plus CD square by AD square plus CD square. After that, we find it discomfort to go for further simplification. Then what best thing we can do? Observe. Here ACB is a right angle triangle. See that? And from angle from the vertex we have drawn perpendicular. Immediately you can go for recalling one of the important theorem before which we come across the Pythagoras theorem. Can you recall it? Yes, it is. If a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then two triangles are formed, and each of these triangles is similar to the given triangle. That means ADC is similar to ACB, then CDB is also similar to ACB. Now see that AC is the side of both the triangle, the small triangle and the whole triangle. We get AC square. BC is the side of the main triangle as well as the small triangle. Clear? And we shall go for writing that statement. So pausing the video, you copy from there to here. Afterwards, you can start writing the proof with me. I'll write the statement. What is that? We know that if a perpendicular is drawn, please go on writing with me. perpendicular is drawn from the vertex of right angle of right triangle to the hypotenuse, then two triangles, see, this is first one and the second one, two triangles so formed are similar to what? The given triangle. So according to this statement, how do you go for writing? That is, triangle 1 is similar to given triangle ACB. Please do remember, I had drawn the figure like this. See that this is A, C, B. Next, we can move in this way. A, B, C. Next, C, D, B. In this order. Triangle ADC similar to triangle ACB. Now, we all know that when two triangles are similar, their corresponding sides will be the same ratio. Then how do you write? It is AD by AC is equal to DC by CB or BC is equal to AC by AB. Followed? See, we want BC square by AC square. Here, are there any ratios in which same side is there? Yes. What are those? The first and last ratio. This has been written from CSST, corresponding sides of similar triangles. Now observe here, AC into AC, this is AC square is equal to AB into AD. You may call this as statement 1. Similarly, according to the given statement, second triangle is also similar to the given triangle. Which is that second triangle? See that CDB. Triangle CDB is similar to triangle ACB. Again, by using CSST, we can write CD by AC is equal to DB by CB equal to CB by AB. Followed? Here I write CSST. Then which two ratios can be taken in which the common side is there? Here CB and CB. I'll go for taking first, second and last. Then in this CB into CB, CB square or else BC square, which is equal to, again this is AB into DB. AB into DB. You may call this as statement 2. Here, observe. We want BC square by AC square. What operation can be taken by taking statement 1 and 2? Very good, division. So, should we divide 1 by 2 or 2 by 1? 2 by 1 because BC square is there. So, divide statement 2 by statement 1. Then it is BC square, LHS part. Here AC square, which is equal to AB into DB is equal to AC square. AC square is AB into AD. Observe, AB and AB get cancelled. Remaining DB by AD. DB is nothing but BD. So BC square by AC square is equal to DB by AD or else as given in the statement BD by AD. Hence it is prove. Hope that you have all have understood this, and you can expect this question for 2 marks. So for that you will have to write all these steps. For 1 mark, if they ask you to just they'll give you AC and the side BC. For example, this is 3 centimeter and this is 4 centimeter. If it is so, then they'll ask you to find out AD by BD or BD by AD. Suppose BD by AD is asked. How do you go for writing? BD by AC is nothing but BC square by AC square. What is BC square? 4 square, 16. AD square, 3 square, 9. So the ratio is 16:9. Like this question can be asked for 1 hour. So please do remember this. Okay, copy this one. Dear students, we are moving to another important theorem that I have already written. It is converse of Pythagoras theorem. Can you do? What is the converse of the theorem? The theorem in which, or the statement in which, the data and to prove are interchanged. That is called the converse of the theorem. So, if you want to make the statement of converse of Pythagoras theorem, you must know what is Pythagoras theorem. What is that? See, in any right triangle, the square of hypotenuse, that is AC square, is equal to sum of squares of other 2 sides, AB square plus BC square. If one angle is 90 degree, then the square of hypotenuse is equal to sum of squares of other 2 sides. But converse, in any triangle, if the square of one side is equal to the sum of squares of the other 2 sides, then the angle opposite to the first side is 90 degree. That is the statement. Got it? Yeah. Please go on writing it. First you write theorem 6.9. Then after that, converse of Pythagoras theorem. Write it as a question. Prove that, right, in any triangle, the square of one side is equal to the sum of the squares of what? Squares of other 2 sides. Very good. Other 2 sides. Then the angle opposite to first square, the angle opposite to first side is right angle, nothing but 90 degree, right angle. So here just write the word if in any triangle the square of one side is equal to the sum of squares of other 2 sides, then the angle opposite to first side is right angle. Okay, let's go for proving this. To prove this, what is the first step to be followed? Very good. It is drawing the appropriate geometrical figure. Which triangle should be drawn? Yes. Let us go for drawing a triangle in which square of one side is equal to the sum of squares of other 2 sides. We do not know whether it is right triangle, just we are drawing like it should appear like a right triangle. ABC. Written up? Okay. Write the data with me. What is that? They are given in triangle ABC, they are given square of one side is equal to the sum of squares of other 2 sides. Square of one side, that is AC square, is equal to AB square plus BC square. Followed? Next, to prove, what we are going to prove? Here we have taken AC as the first side. Then the angle opposite to this first side is angle B. Angle B is 90 degree. Here I will write angle B is 90 degree. Then how to prove this one? To prove, I'll write that here. To prove angle B is 90 degree. To prove this, logically, we need to go for construction. Actually, for in practical way, you can find out AB square plus BC square, and AC square. Then this will be whole good. Then the angle opposite to the first side will be equal to 90 degree on measuring. But it should be proved logically. To prove this, we need to go for construction. What is that construction is? We have to draw a triangle, another triangle PQR, such that I take AB equal to BC. In that triangle, AB equal to BC, and one angle is 90 degree. Let me draw one such triangle. Draw right triangle. Right triangle PQR, in which angle Q is 90 degree, PQ equal to AB. Then another one, QR equal to BC. QR equal to BC. Followed? Let me write the same. Construction. You may write with me. Construction. Draw right triangle PQR, in which angle Q is 90 degree, such that PQ equal to AB. PQ equal to AB, and another one, QR equal to BC. QR equal to BC. Written up. Let's go for the proof. Proof is very simple. Now please stop writing. Just keep observing the board. Look here. These are the two triangles in which one pair of corresponding sides are equal. If another pair are also equal, then what do you say about these two triangles? They are congruent according to yes. But do we know AC equal to PR? No. So first we have to prove AC equal to PR. After that we can go for using congruency rule. After proving all this, think that ABC is congruent to triangle PQR. Then angle B equal to angle Q, right? Because CP. Angle Q is 90 degree. What about angle B? B is 90 degree. Hence it is proved. Got it? Dear students, converse of Pythagoras theorem can be proved easily by proving both the triangles as congruent. So in proof, first I will take the triangle PQR. In triangle PQR, angle Q is 90 degree, right? Q equal to 90 degree. Then what type of triangle it is? It is a right triangle. Then which theorem can be applied? Very good. By Pythagoras theorem. By Pythagoras theorem, you can write the square of the hypotenuse, that is PR square, is equal to PQ square plus QR square. PQ square plus QR square. Next, what is PQ? PQ is nothing but AB. It is AB. Then QR is BC. So we can write AB square plus BC square is equal to PR square. So this has been written from construction. Followed? You may call this as statement 1. And we also know that AC square is equal to AB square plus BC square, right? How? It is from data. They only have given. Look here. By observing statements 1 and 2, you can come to know that these are the two different things equal to the same thing. Then obviously they are equal to one another. Hence we can write from statements 1 and 2 and Euclid's axiom. How do you write? It is PR square is equal to AC square. Then square and get cancelled. We will get PR is equal to AC. See that this part is very important. Now we got PR equal to AC. Observe both the triangles. In both the triangles we can come to know that the corresponding sides are equal, right? And dear students, as this triangle is from construction, hence the sides should be in dotted line. Okay. I'll go for taking both the triangles. In triangle ABC and triangle PQR. In these two triangles, AB equal to PQ, right? AB equal to PQ. This is from construction. Next, BC equal to QR. BC equal to QR. What about the reason? Again, reason is same. It is construction. Then AC equal to PR. What is the reason? From the proved statement. AC equal to PR. Proved statement. Next, all the three pairs of corresponding sides are equal by yes congruency. Triangle ABC is congruent to triangle PQR. Very important. When two triangles are congruent, their corresponding angles will be equal, right? I can write angle B equal to angle Q. The reason is CPCT, corresponding parts of congruent triangle. What is the measurement of angle Q? It is 90 degree. Is it not? So here I write 90 degree. Then angle B is 90 degree. See that here? Angle B is the angle opposite to first side. Hence the converse of the theorem is proved. Here I write hence the converse of Pythagoras theorem is proved. Please go for copying the proof from here to here. Dear students, now we are going to answer for the questions that are given in exercise 6.5. Go through first one. It is sides of triangles are given. Determine which of them are right triangles. In case of a right triangle, write the length of its hypotenuse. Dear students, here they are given the sides of the triangles. But how to identify whether they are the sides of triangle or not, sides of right triangle or not? It is better to go for recalling the right triangle property. See that this is the right triangle ABC, in which AC is the hypotenuse. If in any triangle the square of hypotenuse is equal to the sum of squares of other two sides, then the side opposite to the first side is 90 degree, then you can call it as a right triangle. Very simple. If you want to call these are the sides of a right triangle, the square of one side should be equal to the sum of squares of other two sides. Another very important thing is, in any right triangle, the hypotenuse is greater than other two sides. Followed? Look here. Let's go for verify one by one. First one. This is verification. Don't go for copying. First observe, learn, understand it properly, then you can go for writing that. First one, here they are given 7 centimeter, 24 centimeter and 25 centimeter. Which is the longest side? It is 25 centimeter. First you find out 25 centimeters square. What is 25 square? It is 625. Then find out the sum of squares of other two sides. That is 7 square plus 24 square. What is 7 square? Which is 49. 24 square. It is 576. Add them. 6 plus 9, 15. Carry 1. 1 plus 7, 8. 8 plus 4, 12. Carry 1, 6. It is 625. Look here. Here, 25 square is equal to 7 square plus 24 square. Both the values are 625. Here I'll write 25 square is equal to 6. 25 square equal to 7 square plus 24 square. Now look here. Sides of triangle are given below. Determine which of them are right triangle. Then can we say that first one forms a right triangle? Yes. Why? By Pythagoras theorem. So here I'll write by converse of Pythagoras theorem. The angle opposite to 25 centimeter is 90 degree. Pythagoras theorem, and angle is 90 degree. Therefore 7 centimeter, 24, 25, there are sides of right triangle. Therefore 7 centimeter, 24 centimeter and 25 centimeter are the sides of right triangle. Next, if it is another one, in case of right triangle, write the length of hypotenuse. Which is the hypotenuse? The longest side, 25 centimeter. Another one. Therefore, the hypotenuse is 25 centimeter. Got it? Okay. Now, pausing the video, you may copy from there to here. From second one onwards, you can start writing with me. Look here. Second one, and go on writing with me. Verification. First you take the longest side. Which is the longest side? Very good. 8 centimeter. So 8 square is equal to 64. Then the sum of squares of other two sides, 3 square and 6 square. 3 square plus 6 square is equal to 3 square is 9, 6 square is 36. Then 9 plus 36 is 45. 64 is not equal to 45, and obviously 8 square is not equal to 3 square plus 6 square. Therefore, they are not the sides of the triangle. So, it does not form a right triangle. Next, third, verification. Let us check whether they are the sides of the right triangle. 50 centimeter, 80 centimeter, 100 centimeter. The longest side is 100 centimeter. So find out its square. 100 square, it is 1, after that 4 zeros. Because 2 zeros are there. Their square will be 4 zeros. Next, other two sides, 50 and 80. 50 square plus 80 square, which is equal to 50 square. Here 5 5s are 25, 1 0 is there, you have to write 2 zeros. Plus 80 square, 8 square is 64, then 2 zeros. 0 0, 6 plus 5, 9, 4 plus 5, 9, 6 plus 2, 8. Whether 10,000 equal to 8,900? No. We can write 100 square is not equal to 50 square plus 80 square. Therefore, it does not form a right triangle. Hope that you have written the same. Next, let's move on to fourth one. What is fourth one? See that 13 centimeter square, centimeter, 12 centimeter and 5 centimeter. In verification, we can write first longest side, which is that 13. So 13 square is equal to how much? 169. Next, sum of squares of other two sides. 12 square plus 5 square. 12 square is very good, 144. 5 square, 25. Add these two. 9, 6, 1, 169. Now we can write 13 square is equal to 12 square plus 5 square. So it forms a right triangle. If it is right angle triangle, which is the hypotenuse? See, it is 13 centimeter is the hypotenuse. Therefore, the hypotenuse is 13 centimeter. Got it? Here you can write by converse of Pythagoras theorem. It forms a right triangle. Clear? Yes. Now, if you have not written, please go for copying this. Yes. Dear students, please go through second one. This is PQR is a triangle right angled at P. That means PQR is a right triangle. And M is a point on QR such that PM perpendicular to QR. We have to show that this statement. PM square equal to QM into MR. Is it not simple? Definitely. Observe it. First, let me go for drawing the appropriate geometrical figure. They only have given PQR is a right triangle. Hence, I draw right angled triangle. Observe this. And let us name this as PQR. But remember, right angle is P. This is angle P. This vertex is Q and is R. M is a point on QR. This one. Such that PM perpendicular to QR. PM perpendicular. See that it should be right angle. PM perpendicular to QR. And with this information, we are going to prove that PM square equal to PM square. It is equal to QM into MR. QM into MR. How do you go for finding? It is very simple. Look here. If you want to get PM square, then as we know that PM is the side of two triangles, right? One is triangle RPM and another one is PQM. Followed? Hence, we can go for using the theorem 6.7, right? 6.7, which we learned before Pythagoras theorem. That should be recalled. Okay. How do you go for calling these two as similar? Very simple. The perpendicular drawn from vertex of right angle of right triangle to the hypotenuse divides the triangle into two triangles, and each of these triangles is similar to the given triangle, and also they are similar to one another. Followed? So let's go for using that statement. Using that statement, how do you go for writing? Very simple. Okay. If you consider this is in this way, and we should move like this. Here QMP. Please don't go for writing. Just observe. Triangle QMP is similar to PMR. Okay. Triangle PMR. I'll write the statement later. Just keep observing. If two triangles are similar, their corresponding sides will be in the same ratio. Now we can write QM by PM is equal to MP or PM. MP by MR. Next, it is QP by PR. See that? There we want PM square. Here PM and MP are there. Hence I go for considering these two. So PM into PM square. Then this is QM and this is MR on cross multiplication. Followed? Here CSST. Corresponding sides of similar triangles. So for proof, the very important statement to be written is, what is that? Do one thing, you just go for copying from there to here. Afterwards, you may start writing the proof with me. Yes, here we know that if the perpendicular is drawn from the vertex of what? The vertex of right angle of right triangle to the hypotenuse. Then it forms two similar triangles. Then the two similar triangles are formed. Hope that you have written with me. Then after that, copy from here. Triangle QMP is similar to PMR. From CSST, we have written these three ratios which are equal, and take first two ratios, go for cross multiplication. On cross multiplying, you will get PM square equal to QM into MR. So hence the statement is proved. Hope that you have understood. Now please go for copying from there to here. Dear students, here they have given third one. It is similar to the previous one, second one. Please go through this, and the results must be remembered. I'll tell you how to remember them in an easiest way. Once you go through the given statement. In this figure, ABD is a right triangle in which right angle is angle A, and AC is perpendicular to BD. With this information, you have to prove AB square equal to BC into BD. See that? AB square equal to BC into BD. Followed. Next, AC square equal to BC into DC. And AD square is equal to CD into DB. Follow? Remember like this. When you come across this side, AB, follow from here. AB square equal to BC into BD. AD square equal to CD into CD into DB. Then AC square equal to BC into CD. Followed? But how to prove them? Just I go for giving you the hint, and it should be proved by yourself. First, AB square is there. Okay, AB. If you want to get AB square, then you have to take two triangles. They are, one is DAB. See that? This part, DAB is similar to ACB. See that? ACB. Followed? Then you have to prove those two triangles are similar. Then after that, use that CSST, corresponding sides of similar triangles. Then you will get AB square. Next, we want AC square. If you want to get AC square, just we wrote the statement that the perpendicular drawn from vertex of right triangle to the hypotenuse will divide the triangle into two similar triangles. Hence, these two triangles, which are, one is DCA and ACB are similar. Use CSST and prove this statement. Third, AD square equal to BD into CD. AD square. See that? AD is the side of the main triangle. AD is also side of this smaller triangle. Hence, you should take the triangle in the order as DAB is similar to DCB. That should be proved. DCB. Then you will get this statement by taking CSST. Hope that you are able to do that yourself. And this is for homework. Try this one. Dear students, in today's class, we proved some important statements. Then after that we come across the converse of Pythagoras theorem. That is also very important in the examination point of view for 2 marks. Then based on converse of Pythagoras theorem and using similarity concept, we are proving some other statements. And this is third one. So please do practice all of them, what we have covered today. Practice them today itself without fail. Okay? And tomorrow also we are going to continue the same chapter. With this, let us stop the class. Thank you very much.